One issue that can plague intense TVSs is called velocity aliasing. Every radar has a maximum unambiguous velocity, or Vmax. If a target is moving so fast that it exceeds the amount of phase shift the radar can detect, its velocity will become ambiguous, meaning that the radar might think that it's stationary or moving the opposite direction at a much different velocity than what it actually is. Because it applies to both inbounds and outbounds, the maximum unambiguous velocity, which is also called the Nyquist velocity, dictates the range of velocities that can be observed without this ambiguity. In other words, velocities that fall between positive and negative Vmax will be estimated accurately in velocity data. This range is called the Nyquist interval. Sometimes, winds within a TVS can be so intense that they exceed the Nyquist velocity, which causes them to exhibit much different velocities on radar than they actually have.
The Chaser Academy is our premium subscription, and it's the best deal in storm chasing. Link in the description.
For example, let's say a radar with a Nyquist velocity of plus or minus 70 miles per hour is sampling a TVS. Let's say a target within the TVS has an actual outbound velocity of 100 miles per hour. The radar will attempt to estimate the target's velocity, but it maxes out at 70 miles per hour. To compensate for this, the velocity folds over to the other end of the Nyquist interval and continues along the interval to account for the remainder of the velocity. In this case, the Nyquist velocity is 30 miles per hour shy of the target's actual 100 mile per hour velocity, so we'd go an additional 30 miles per hour, which gives us a radar estimated velocity of negative 40 miles per hour. So, the radar thinks that our target, which is actually traveling at 100 miles per hour away from the radar, is instead traveling at 40 miles per hour toward the radar. Let's say our outbound target was traveling at 150 miles per hour. The radar would read it as 70 miles per hour plus another 70 miles per hour plus the remaining 10 miles per hour, giving us an output of 10 miles per hour away from the radar, much different than the target's actual velocity. This can make TVSs and other signatures of intense winds difficult to properly analyze. Instead of a symmetric signature between adjacent enhanced inbounds and outbounds, you might see inbounds where there should be outbounds and vice versa, as in this example. Thankfully, all National Weather Service radars use an algorithm to de-alias velocity data, so most of the time we don't have to worry about velocity aliasing. Still, the algorithm can leave behind some aliased velocities at times, so it's good to know what to look out for.
Remember to check out those links in the description below, and then watch another video.